In this video, we're going to look at Chapter 18, Section A, on radian measures. Remember from Chapter 10 that we can measure angles, which I'll denote with the symbol theta, using degrees. And there are 360 degrees in a circle. In this chapter, we're going to use radians instead of degrees to measure angles. This is a lot like measuring length in meters or feet. Both are accepted measures. And so I'm going to teach you a new way to measure angles, and that's using radians. And radians are based on arc length. And an arc is simply a segment of a circle's circumference. Right, so if I was to just pick this arc right here, that's a section of the circle's circumference. And in radian measures, we still start on the positive x-axis, and we still start with 0. Remember from geometry that the circumference of a circle is equal to 2 pi r. But also note that the radius of a unit circle is equal to 1, so that the circumference of the unit circle is really 2 pi. We know that there are 360 degrees in a circle, and we know that the circumference, or the measure of the length of the entire unit circle, is 2 pi. That is an arc length. That can also be used to measure the angles, or the full sweep of a circle. So 360 degrees is equal to 2 pi radians. Do a little bit of algebra here, and we find that 180 degrees is equal to pi radians. And we usually ignore the symbol for radians, which is kind of half of a degree symbol. We don't write that, and we just write pi radians. This relationship is so important, and it's so worth remembering. I'm going to just write it again. 180 degrees is equal to pi radians. And from that relationship, we can equate any angle in degrees to any angle in radians. From the last slide, we saw that pi radians is equal to 180 degrees. If we divide both sides of the equation by pi, we see that 1 radian is equal to 180 degrees divided by pi. And this is roughly 57.3 degrees. Here is a unit circle with one radian arc length drawn on the circle. You can see it right here. So 1 radian is approximately equal to 57.3 degrees. Now it may seem that 1 radian is small because we're using the number 1, but really it's almost it's over half of the distance between the positive x-axis and the positive y-axis. So again, the definition of a radian is 1 radian is the angle swept out by an arc length equal to the radius of the circle. So in this case, the radius is 1, so 1 radian is the angle swept out by an arc length equal to 1. And that's true for any circle. We can scale it up or down using any radius. If we're interested in finding the length of an arc AB in a diagram like this, where we know the radius and theta, it's actually much easier to use radians than degrees. If we were to measure the arc length using degrees, we would get theta times r, but then we would have to convert that using 2 pi divided by 360. if we use radians, the arc length simply becomes theta times r. Now let's take a look at a few examples of how to convert between degrees and radians and between radians and degrees. In this example problem, we want to convert 150 degrees to radians in terms of pi. We're going to use a conversion factor here, which simply is that pi is equal to 180 degrees. Now essentially we want the degrees to cancel out, so we're going to multiply by the conversion factor in the form of pi divided by 180 degrees. We know that pi and 180 are equal, so really I'm multiplying by 1 here. Notice that the degrees will cancel out, and I'm left with 150 times pi over 180. With a little simplification, we see that this is equal to 5 pi divided by 6. So 150 degrees is equal to 5 pi over 6 radians, or 5/6 pi. Let's look at another example. Let's convert 131.8 degrees to radians. We can use the same method. We'll multiply 131.8 degrees times pi over 180. And this time we'll have to use our calculator to approximate the answer using decimals. And if we use three significant figures, we'll get 2.30 radians. Now this is where it's useful to use the symbol for radians when we're having just a number without pi. In this example problem, we want to convert 7 pi over 6 radians to degrees. So again, we're going to use a conversion factor, and it's actually pretty much the same conversion factor, except it's switched. We're going to multiply by 180 degrees over pi. This is because the pi's will now cancel out, and I'm left with 7/6 times 180. This is really 7 times 30, so I'm going to get an answer of 210 degrees. Now let's look at converting 1.237 radians to degrees. Again, we're going to use the same conversion factor. I'm going to multiply by 180 degrees over pi. And here I'm going to need to approximate the answer using my calculator. And if I do that, I'm going to get an answer of 70.9 degrees. There's a great graphic in your textbook in this section on which conversion factor to use when. Remember, we're going to convert degrees to radians by multiplying by pi over 180. We're going to convert from radians to degrees by multiplying by 180 over pi. And that's a really useful thing to remember for this chapter.